There's a $1 mixture that removes tarnish from silver in seconds without rubbing, not chemical cleaners that strip protective layers, not abrasive polishes that gradually wear metal away, a simple electrochemical reaction that lifts tarnish from the surface, leaving the underlying silver completely undamaged. One immersion in hot water with 2 household ingredients and blackened silver emerges mirror bright in 30 seconds. A museum conservator at the Smithsonian used this method exclusively on tarnished silver artifacts in the 1970s. 45 years of treatments on priceless historical pieces with 0 damage to underlying metal or patina. The global silver care product industry generates over $800 million annually. Silver polishes, cleaning solutions, and professional restoration services account for $600 million of that total. The average household with silver flatware or jewelry spends $45 yearly on cleaning products. The entire industry depends on abrasive polishes that require continuous elbow grease, chemical solutions that need frequent reapplication, and professional services for heavily tarnished pieces. A $1 mixture using baking soda and aluminum foil that instantly removes any level of tarnish cannot be sold as a premium product. It cannot generate repeat purchases. It cannot justify professional service fees. This is the story of electrochemical tarnish removal, the method every jeweler knows but never teaches customers, and the oxidation reduction reaction the silver care industry buried. Welcome to Forbidden Camping. If this knowledge matters, the subscribe button is how you make sure it survives. In 1791, Italian scientist Luigi Galvani discovered that chemical reactions could produce electrical current. His experiments with dissimilar metals in solution laid the foundation for electrochemistry. By 1830, scientists understood that silver tarnish is silver sulfide, a black compound that forms when silver reacts with sulfur in air. Traditional polishing removes tarnish through mechanical abrasion, literally grinding away the tarnished layer. This works but removes tiny amounts of silver with each polishing. Over decades, heavily polished silver pieces lose detail and weight. Electrochemical cleaning reverses the tarnishing reaction without removing any silver. When tarnished silver contacts aluminum in a basic solution, electrons transfer from aluminum to silver sulfide. This breaks the sulfur-silver bond. The sulfur binds to aluminum, forming aluminum sulfide, while pure silver remains on the object. The tarnish literally transfers from silver to aluminum. No scrubbing required, no silver lost. The reaction is instant and complete. By 1880, jewelers and silversmiths knew this technique. Trade journals published detailed instructions. The method was considered professional knowledge shared among craftsmen. But when the commercial silver polish industry emerged in the early 1900s, companies like Haggerty and Wright's Chemical began marketing paste polishes and liquid cleaners as modern scientific solutions. These products generated ongoing sales because they wore out, required reapplication, and needed elbow grease that convinced customers they were doing real work to achieve results. Electrochemical cleaning was repositioned as unsafe or unreliable, despite being the gentlest method possible. Industry marketing emphasized that proper silver care required specialized products with secret formulas. The goal was creating product dependency. You cannot patent baking soda and aluminum foil. You cannot trademark an electrochemical reaction discovered in 1791. You cannot build a product line around something anyone can do in their kitchen sink for pennies. So the knowledge disappeared from consumer awareness. By 1950, silver care guides published by manufacturers recommended only their branded products. Jewelry stores sold polishing cloths and pastes without mentioning alternatives. Home economics courses taught mechanical polishing as the only proper method. The electrochemical technique survived only in professional restoration workshops and museum conservation departments where preserving original metal was paramount. If you have made it this far, you know more about silver care than most jewelers share with customers. Subscribe now and share this with someone about to pay $60 for professional silver polishing. Everything the silver care industry buried is inside the complete Forbidden Camping vault. The copper cleaning method using vinegar and salt that works in minutes, the brass restoration technique that removes decades of oxidation, the chrome polishing solution using aluminum foil for spotless results, the stainless steel scratch removal using baking soda paste, the gold jewelry cleaning method that restores original luster, and now the silver electrochemical treatment that removes any tarnish instantly. 6 metal restoration methods in one vault, 0 filler, every page built for immediate use. The link is in the description. But stay here because the chemistry behind this is the most shocking thing you will hear. Here's what happens at the atomic level during electrochemical silver cleaning. Silver tarnish is silver sulfide with the chemical formula Ag2S. This compound forms when silver reacts with hydrogen sulfide in air. Hydrogen sulfide comes from pollution, eggs, rubber, wool, and many household sources. Even small concentrations cause silver to tarnish over time. The black coating is not dirt or corrosion. It is a chemical compound bonded to the silver surface. Mechanical polishing removes this compound by abrading it away along with a thin layer of underlying silver. Electrochemical cleaning reverses the reaction that created the tarnish. When you place tarnished silver in contact with aluminum in a basic solution, you create an electrochemical cell. Aluminum is more reactive than silver in the electromotive series. This means aluminum more readily gives up electrons. In the basic solution created by baking soda dissolved in hot water, aluminum atoms lose electrons and become aluminum ions. These free electrons flow to the silver sulfide. When electrons reach silver sulfide, they break the bond between silver and sulfur. The sulfur atoms bind to aluminum, forming aluminum sulfide. The silver atoms remain on the object but are now pure metallic silver rather than silver sulfide. The tarnish has been chemically converted back to silver without removing any metal. You can see the reaction happen. As tarnished silver touches aluminum, the tarnish literally disappears in seconds. The aluminum foil develops a dark coating as it accepts the sulfur. You are watching electrons flow from aluminum to silver, reversing months or years of tarnishing in 30 seconds. The reaction requires three components. First, aluminum provides the electron source. Aluminum foil works perfectly. Second, a basic solution allows ion movement. Baking soda dissolved in water creates this environment. Third, heat accelerates the reaction. Hot water speeds electron transfer, making the process nearly instant. The hotter the water, the faster the reaction. Boiling water produces results in under 10 seconds. Warm tap water works in 30 to 60 seconds. A study published in the Journal of Chemical Education in 1982 tested electrochemical silver cleaning against commercial polishes. Researchers tarnished identical silver samples using sulfur exposure until uniformly black. They cleaned half using leading commercial silver polish with standardized rubbing time. They cleaned the other half using aluminum foil and baking soda solution. Spectroscopic analysis measured silver loss. Commercially polished samples lost an average of 2.3 microns of silver from the surface. Electrochemically cleaned samples lost 0 measurable silver. Visual inspection showed both methods produced equally bright results. The electrochemical method was faster, required no physical effort, and preserved all original metal. The study concluded that electrochemical cleaning was superior for preserving silver objects. Published in an educational chemistry journal and ignored by the silver care industry. Here is exactly how to perform this treatment on any tarnished silver. Line a glass or ceramic bowl with aluminum foil, shiny side up. Avoid metal bowls, which can interfere with the reaction. Boil enough water to completely submerge your silver items. While water heats, add 1 tablespoon of baking soda per cup of water to the foil-lined bowl. When water reaches a rolling boil, carefully pour it into the bowl over the baking soda. Stir briefly to dissolve the powder. The solution will be clear and slightly cloudy. Place your tarnished silver items into the hot solution, ensuring each piece contacts the aluminum foil. This contact is essential for electron transfer. If items do not touch foil naturally, use a wooden spoon to press them against the foil. Watch the tarnish disappear. Heavily tarnished pieces show dramatic transformation within 10 to 15 seconds. Light tarnish vanishes almost instantly. For extremely heavy tarnish covering the entire surface, you may need to flip items to ensure all areas contact aluminum. The reaction works on any silver regardless of how black the tarnish. Items that have been tarnished for decades respond identically to recently tarnished pieces. After 30 to 60 seconds, remove silver items using plastic tongs or wooden utensils. Rinse thoroughly under warm running water to remove any residual baking soda solution. Dry immediately with a soft cotton cloth. The silver will be mirror bright with all tarnish removed. Intricate details, engravings, and textures that are impossible to reach with polishing cloths are cleaned perfectly because the reaction occurs everywhere simultaneously. For silver with intentional oxidized details like blackened engraving backgrounds, use this method carefully. The reaction does not distinguish between unwanted tarnish and intentional oxidation. Both are silver sulfide and both will be removed. To preserve oxidized details, avoid immersing fully. Instead, use a cotton swab dipped in the hot baking soda solution and apply only to areas where you want tarnish removed. For large items like serving platters that do not fit in bowls, line a sink with aluminum foil, add baking soda, fill with hot water, and immerse the large piece. For silver chains and jewelry with multiple links, lay items flat in the solution, ensuring all surfaces contact aluminum. A jewelry collector in Connecticut documented complete restoration of a heavily tarnished Victorian silver tea set using this method in 2014. The set included teapot, sugar bowl, creamer, and serving tray. All pieces were completely black from decades of neglect in storage. Professional restoration quotes ranged from $300 to $500. The collector purchased $2 worth of aluminum foil and used baking soda already in the pantry. She treated each piece individually in a foil-lined roasting pan with boiling water and baking soda. Total treatment time for all 4 pieces was under 10 minutes. The silver emerged brilliant with all ornate Victorian detailing perfectly cleaned, including areas impossible to reach with polish. The set appraised 6 months later showed no damage and increased value due to excellent condition. Total cost was $2 for aluminum foil. Professional service would have cost $400 minimum. Important considerations for optimal results. This method works on pure silver and sterling silver, which is 92.5% silver. It does not work on silver-plated items because the reaction removes silver sulfide, which is what you want, but it can also remove thin silver plating if done repeatedly or for extended time. For plated items, limit immersion to 10 seconds maximum. This method is safe for silver with gemstones as long as the stones are securely set. The reaction only affects silver, not stones. However, avoid using on silver with glued-on elements as hot water may loosen adhesives. Do not use this method on antique silver with valuable patina you want to preserve. Museum pieces and collectibles often have aged appearance that adds value. This method will make them look new, which may actually decrease collector value. For everyday flatware, jewelry, and decorative pieces, this method is ideal. After cleaning, silver will tarnish again over time when exposed to air. This is normal. Store cleaned silver in sealed bags or anti-tarnish cloth to slow the process. When tarnish returns, simply repeat the treatment. Unlike mechanical polishing, which eventually wears items thin, you can use this method indefinitely without damaging the silver. The aluminum foil develops dark coating during the reaction. This is aluminum sulfide forming as sulfur transfers from silver. The foil can be reused several times until heavily coated, then simply discard and use fresh foil. Baking soda solution can be poured down the drain safely. It is non-toxic and actually helps clean drains. This knowledge did not disappear because it stopped working. It disappeared because it worked so well that an $800 million silver care industry had to make sure consumers never discovered they could restore any tarnished silver in seconds for pennies using kitchen ingredients. For over a century, Polish manufacturers and professional services have known that electrochemical cleaning is faster, gentler, and more effective than any product they sell. But a method costing $1 that works instantly cannot generate the continuous product sales necessary to support manufacturing, distribution, and retail networks. The chemistry has been documented in electrochemistry textbooks since Galvani's original experiments. The efficacy has been proven in museum conservation applications on irreplaceable artifacts. The safety has been established through professional use in jewelry and silversmithing trades for 200 years. But a solution that costs $1 and requires no special products cannot coexist with a business model built on selling abrasive polishes, chemical cleaners, and convincing consumers that proper silver care requires branded products and professional expertise. So they buried it beneath generations of marketing that made mechanical polishing seem like the only legitimate method, while electrochemical cleaning was omitted from consumer guides and dismissed as a questionable shortcut. The suppression was systematic, institutional, and almost perfectly effective. If this changed how you see your tarnished silverware, subscribe and share now. Every share cracks open a vault they welded shut.